Okay. So yesterday we covered main group. So we covered the first one that's on there, on that front page. Today we're going to talk about the other two types of ionic compounds, and then we'll also discuss briefly the molecular compound and how to do that. So yesterday we did main group and main group, right? We did main group metal, main group non-metal, all of which are the common charges from the periodic table. Remember, +1, +2, +3, -3, -2, -1. Based on where it's located, it has a specific charge. Type 2, sometimes referred to as the stock system. This is going to involve a transition metal with many possible types of charges. We're always going to name the metal first. When we name metals, we just write the elemental form. Okay. So let's look at we're going to add a Roman numeral. The goal of the Roman numeral is to tell us what the charge on the metal is. So for something like vanadium, 3+, okay. When we name the metal, we're going to write out the name from the periodic table. Then we're going to indicate the charge of the metal with a Roman numeral. Okay. The reason we do this is because it can have multiple charges. So you're going to have to remember your Roman numerals up to 5. 1, 2, 3, 4, and 5. Okay? In these compounds, there's like subtype, right? Subtype 1 is going to be main group nonmetals, which we're going to use the same way we did in type 1, where we write the ending of the nonmetal gets dropped and we add IDE. I have to have a Roman numeral here, right? And so one of the things that we have to learn with these types of metals specifically is how to determine the charge. We're going to have to use the thing it's attached to determine the charge on the metal. In this particular case, we're going to do the reverse of the cross method. What's the fictional number that belongs after the V in this formula? A 1, right? Is the typical charge on a chloride a -1? Look at where it's located. You should agree with that. So, V is going to have to be a 3+, because there are 3 chlorines that are each a -1, right? So we can uncross our subscripts to figure out what our superscripted charges should be. Just remember that the metal is always positive and the nonmetal is always negative. In this particular case, did I have to do that? No. If I knew there were 3 chlorines and I knew each one was -1, I can do the math in my head and say, okay, well, for this to be -3, the metal must be +3. But it gets really useful when we get to things like this. Is Fe a transition metal?
Yeah.
Absolutely. So that means we have to use a Roman numeral, right? And in order to use a Roman numeral to describe what the name of this is, we need to know its charge. In this particular case, we determined that vanadium was a 3. So we're going to add that to our name always. In this particular case, we're going to do the opposite that we just did, right? We're going to uncross them. We're going to get that Fe should be a 2 plus, N should be a 3 minus. Should N be a 3 minus charge? Yeah, based on where it's located, it should be. So this is the first type of the stock system of nomenclature that we can write. So then what would I write? What did I start with? Iron. 2 nitride. Okay, let's go the other way. Yes?
So for Cl, how would the 3 be in front of it when you do like the cross?
Well, remember, it goes with the metal.
Oh.
Remember? The Roman numerals go with the thing in front of it, not with the thing after.
Okay.
That make sense?
Yeah.
Okay. All right, so this was the forward direction. Remember we talked about forward and reverse yesterday? This is forward. In this type of compound, the reverse is easier because you're given one of the charges. The other one's going to be a common charge. Okay, so in the reverse direction, remember that the reverse direction is we're given the name and we're going to the formula. You can sit where Ava usually sits if you like. All right. Name to formula. Let's go with, ooh. Okay, so, oops. Sorry, I wasn't supposed to give you that, was I? I was supposed to give you this. My bad. What number is that? 4. Okay, so we're going to start with what we know. We're going to write out our 2 atoms just like we did yesterday. We're going to do the cross method to figure out what our formula should be. So W is tungsten. We know it's a 4 plus. Oxygen is oxide, right? What is oxygen's typical charge? -2. Then what do? We're going to cross them. Circle just the number. And we're going to rewrite. What can we still do? Simplify the numbers, reduce them to that. So in my opinion, that's the easier of the 2 ways to go, right? Because for this one, you have to do some problem solving to figure out what the charges are before you can write the formulas. One of the things I'm going to recommend to you is when you sit down to write these different names out, when you're going from formula to name, go through and star all of the ones that you know are going to have Roman numerals. It's what I do on my answer key too. So if there's a star next to it, you know you're going to have to use a Roman numeral because it's located in an area where it needs one. And remember that yesterday we talked about the 2 metals that have to have Roman numerals, even though they are not technically transition metals. We talked about these. Tin and lead must have Roman numerals. Need RNs, also known as nurses. Yes?
How do you know that tungsten has a charge of 4?
It told you in the name.
Oh, okay.
This was when we went from name to formula.
Oh.
Remember? Okay? Good question. Okay, yes.
So it says W2O4. How does it turn into WO2?
We reduced it. So we divided the subscripts by 2 to get our lowest one to be 1. You always want one of your numbers to be as low as possible, right? Cannot be divided by anything but itself. You want them to be primes.
So
Yes.
how would we write the steps for the type 2 on this paper?
Same way that we talked about yesterday. So step 1 would be to identify if the metal is a transition metal or not. Right? Step 2 would be write the metal name first, with the Roman numeral following it. And step 3 would be to write the nonmetal with the ending where you drop IDE. All right. Our last one brings our polyatomic ions into play. Okay. Polyatomic ions don't do that much. In fact, they're a little bit easier. If you know their names, you just write their name. You don't have to change their endings. Their charges are set, right? If you know the charge on a polyatomic ion, that's going to help you identify the charge on the metal that's attached, especially if that metal is a transition metal, right? So if I give you something like iron nitrate, FeNO3, 2, you can use the charge on the polyatomic ion that you have now memorized, boys and girls, to determine the charge on the metal. This was the point of the polyatomic ions. Naming with polyatomics. We can name main group metals with polyatomic ions. We can name transition metals with polyatomic ions. And we can name compounds where there are polyatomic ions and nonmetals, or 2 polyatomic ions. Oh boy. Polyatomics do not have name changes. Follow rules for metal naming as given. If main group, no Roman numeral, remember? You just name the metal. If transition metal, add the Roman numeral. My hand hurts. Okay. If you're given a polyatomic plus a nonmetal, name polyatomic first. Then nonmetals, same way we've named all nonmetals up to date. What do we do to them? Okay, so let's do some examples of each of these different ways that polyatomic ions can come into our lives. Way number 1. You're going to notice that I am very picky about parentheses with my polyatomic ions. I will put a parenthesis in there all the time. In this class specifically, I am very picky about parentheses with my polyatomic ions. Because I want you to recognize that charges go with the whole ion. They don't go with one atom. If I go to uncross my charges here to figure out what the metal charge is, which I don't need to do because I know what sodium's charge is in this particular case, but pretend I was trying to figure out what the charge on this thing was, right? Then what I need to do is I need to make sure I realize the subscript of the polyatomic ion is outside the parenthesis. Okay? Do not mess with anything inside of a polyatomic ion. That's why I wanted you to memorize them the way they were written. Do not change anything inside a polyatomic ion. Pretend it's a red circle, okay? Don't touch anything in the red circle. Okay. So we've got our subscripts on the outsides. What's the fictional one out here? A 1, right? Should this thing be a +1? Yeah. If I uncross these, do I get that this is a 2 minus and this is a 1 plus? I do. Is that correct? Sulfate should have a -2 charge, shouldn't it? Okay. How do we name it? Sodium is a known main group metal, so it just gets its name, and then we just name the polyatomic. All right, now let's do a transition metal. Ooh, this one's tricky. I like it. Okay, so in order to figure out the charge on this guy, I need to have this one memorized, don't I? What's the charge on the C2O4? -2. What does that mean the silver has to be in order to make it a neutral compound? Since there's only one of them. This is an example of where the crisscross method can lead you a little astray. If you uncross these, what would you think the charges were? You would think 1 and -1, right? But having memorized that oxalate is a -2 charge, you should not make that mistake. This is one of the trickier ones. Okay, so now we know the charges. How do we name it? Silver. 2. Why do I need the Roman numeral? Transition metal. Oxalate. All right, one more. Well, probably not. That's always a lie for me. All right, let's do... Say again?
Would you put ammonium first because it's positive?
Yeah.
Okay.
You'll start to notice that pattern if you haven't already. The things that are positively charged always come first. The things that are negative always come second. With our ionic compounds specifically, so the ones we're practicing today are all ionic. Positive always comes first. Okay, so do we need to know the charges on anything in this particular one? No. Where do we really need to make sure we know charges? Whenever we see a transition metal, right? Okay. So if I wanted to, though, do we have this one memorized? What is it? And +1. Okay. So we're going to name it polyatomic ion first. Ammonium. Then what? Sulfide. Kick them up. Take your names. Okay, here's another one. This is our last type, I guess. I just have to think. 1 second. What are they? They're both polyatomic ions, aren't they? Do you see that? Do you see how I'm not reducing the numbers? Do you remember what I said about polyatomic ions? Imagine the red circles. You don't touch those subscripts, even for peroxide. And you will see one of those on your practice here in a second. Okay? So do not touch the subscripts when it comes to polyatomic ions at all. Only outside of the parentheses. How do we name it? Yeah, we just straight up write them in order. Positive first, negative second. Okay. How do we feel? A little shaky? That's okay. That's why we're going to practice. All right, in front of you, you have the steps. You can write out what steps you think are important to you, but for the most part, the steps are referring to how do you name the metal. In the transition metals, you have to figure out what the charge is. How do you name the non-metal? If there's a polyatomic ion, how do you name the polyatomic ion? Write yourself some steps to figure that part out. If you have to uncross charges to figure something out, make sure you include that. When you're done with that, move on to page 1. The answer key to page 1 is up on Canvas for you to check when you're done. We don't want you really moving around the room, okay?
Do you need a Roman numeral, just like one? Like Roman numeral for
If it does have a 1 charge and it is a polyatomic, or I'm sorry, if it is a transition metal, yes. Roman numerals will range from 1 to 5. Working on page 1
Yeah.
of the naming activity that I'm going to send you in your email in a minute.